JWT is an important word that you need to know if you are dealing with web development. No matter what language, library or framework you are working with, JWT is a common word between front-end, back-end and also full-stack developers. In a stateful protocol, we will have a session or a sequence of requests for a single user and we know all of previous requests. On the other hand, in a stateless protocol, each request is separate and isolated and all requests are independent. Next, let's see what is authentication and authorization. Let's consider a scenario in which we have a website like YouTube. You have a YouTube channel and you upload public videos on your channel so anybody can see them. But how we can allow the owner of channel to manage his or her channel, like uploading new video, editing channel info and other operations? Well, the owner must log into website. Normally, owner has a username and a password, and if both of them are correct, the owner can log into YouTube account. This is authentication process. After a successful authentication or login, the owner would be authorized to manage the channel. But in every request, we need to be sure that this is the same owner that logged in previously. So, we need to have a way to identify owner in next requests. Therefore, we must have something unique to know the owner, and this is authorization process. So, the big question is, what is this unique something? Generally, we have two methods of authentication and authorization: session versus token. Before token, the session was the answer. Session-based auth is a stateful technique. It means that we keep track of the user in the session. But how session works? User submits a login request with credentials to the server. Then, server validates the credential by searching the database to find a match in user's stored data. If the data was not valid, server would return a response with message of unauthorized attempt and a status code of 401. Or, if the data was valid, the server initiates a session. A session is a small file that stores some information about the user, such as unique ID, time of login and expiration, and so on. This information can be stored in either memory, file system, or database. But the best solution is database. Then server sends the unique session ID to the client via cookies. Now the user has session ID in the cookies and it will be automatically sent to the server in each request after the login. In next request, server will check the session ID cookie and send a request to database to get information about this session and this client. If the session ID was valid, it would continue. Else, server would return a response with message of forbidden attempt and status code of 403. And this is how session works in authentication and authorization. But this is not the best solution. There are some problems like horizontal scaling. When we are scaling an application horizontally, in other words, adding more servers to distribute the load, sharing session data between them can be challenging. Although there are some techniques, but they can introduce additional complexity and potential performance bottlenecks. A stateful nature of sessions. Sessions require the server to maintain and store session data for each active user. So, if instead of database, we save sessions in server memory, it can put a strain on server resources and scalability on a big scale systems with large number of concurrent users. Multiple domains. Using cookies for a single user on different domains can be a problem because cookies usually work on a single domain or subdomains. Also, maintaining and managing sessions state across different platforms and devices can be difficult. Single point of failure. If the server hosting the session data goes down or become unavailable, all authenticated users relying on session-based authentication will be affected. This creates a single point of failure and a bottleneck for our website. RESTful is stateless. Session-based authentication is not well suited for stateless architectures like a RESTful API. RESTful APIs are designed to be stateless, and incorporating sessions can break the statelessness principle. Microservice compatibility. In a microservices architecture, we have different services. Each service would need to maintain and manage its own session data or rely on shared session store, leading to increasing complexity and potential concurrency issues such as single point of failure. Security. Cookies can be vulnerable to cross-site request forgery or man-in-the-middle attacks. Token-based auth is a stateless technique. In this way, user submits a login request with credentials to server. Then, server validates the credential by searching the database to find a match in user's stored data. If the data was not valid, server would return a response with message of unauthorized attempt and the status code of 401. Or, if the data was valid, the server issues a signed token. A token is a special text file that stores some information about the user, such as unique ID, time of login and expiration, and anything else. Unlike session, the token must be generated using a unique secret key that we talk about in a minute. Also, unlike session, this token would not be saved on the database. The server returns the token to the client on response body. The token would be saved on the browser's local storage memory. On each request after the login, the token must be on the request header to be authorized. In next requests, server will check the request header and validates the token using the same secret key that is used to generate this token. The validation is on the server controller and it doesn't require another database request. If the token is valid, it would continue. Else, server would return a response with message of forbidden attempt and the status code of 403. And this is how token works in authentication and authorization. But why token is better than session? They increase performance. Validating a token will be done by a simple function and we just need the secret key, so we don't need additional database query and session management. They are secure. Each token needs a secret key. Anybody can issue a token, but that token is not verified on your server because your secret key is different. They are stateless. Tokens are independent. They contain all the required information to authenticate and authorize the user. They don't rely on server session. They are scalable. When we are scaling an application horizontally, in other words, adding more servers to distribute the load, working with tokens is easier. Each server can validate the token easily and independently. They are compatible to microservices. In a microservice architecture, we have different services. Each service can independently verify the token's integrity and extract user information. So, we don't have increased complexity and potential concurrency issues such as single point of failure. They are compatible to multiple domains. Tokens can be easily transmitted as HTTP headers. Therefore, they are compatible with different platforms, including web, mobile, and IoT devices. Tokens can be used for single sign-on across multiple applications or services. They are manageable. Tokens can be easily customized with an expiration time, after which they become invalid. They gives us a better control over session lifetime. And if we need more control, we can use some token revocation mechanisms and refresh tokens. Now let's see what is JWT or JSON Web Token. JWT stands for Json Web Token. In order to see the structure of a JWT better, let's go to this website to see the structure of JWT. First, let's see what is JSON. JSON stands for JavaScript Object Notation, something like this. And JWT or JSON Web Token is a standard that allows us to securely transmitting data between websites, clients, and servers as a JSON object. JWT has three different parts: a header, a payload, and a signature. The header will show the algorithm used to sign the token. The payload contains the information we need to transfer about the user. It also called as claims. The signature verifies the integrity of the token. But how it works? We can use some header and any payload, but the signature is the most important part on the server. Server will use this function to generate the secret based on the header and payload. Let's check it step by step. First, server creates a new string with these values: base 64 URL encode of the header, a dot, and base 64 URL encode of payload. Then server runs a function like this to generate the JWT with its secret key. Then the generated JWT will be compared with the request JWT, and if they are equal, it means that the income JWT is valid. That's it, simple and easy. But what if someone tampers the JWT? Let's see. I use a secret key like this string. You can see that for each secret key, we have a different signature. So if you change the header or the payload even by one character, the signature would be invalid for this secret key. So this would be an invalid JWT. You can again use another secret key, but you don't have access to the server secret key. And the big point is, the process of making secret with this algorithm is just one way. You can't detect the secret key from the generated signature. Now, let's see a real-world example of JWT. I have this API route and it is protected. So without token, I see this 401 status code. So I send the wrong username and password to login route and I receive a 401 status code again. Now let's send a valid username and valid password to login route. Well, we received the JWT token from the server. In next step, I will send my token in request header and I'm authorized to access this protected content. And this is the header of the request with JWT token. I hope this video helps you. Have a good time and goodbye.